Welcome to the CNC Workshop, the show where we talk through CNC upgrades, workshop problems, and the little technical details that can save you from buying an expensive box full of parts that do not actually talk to one another.
Which is a surprisingly common genre of box.
A very specific genre. Heavy, expensive, and usually delivered on the exact day you planned to install everything.
Naturally.
I'm Jamie, and joining me is Daniel, the engineering brain behind PwnCNC, and the person I intend to bother with all of my automatic tool changer questions.
That sounds about right. Let's do it.
Today's question sounds simple. Does an ATC spindle require a MASSO controller?
The short answer is no.
Great episode, everybody. Thanks for listening.
The complete answer, however, is it depends on what you expect the system to do. There is a big difference between controlling an ATC spindle and performing a fully automatic tool change.
So a controller may be capable of running the spindle without being capable of running the entire tool changing sequence?
Exactly. Starting the spindle, stopping it, and commanding a speed are only the beginning. A true automatic tool change involves motion, compressed air, sensors, tool locations, offsets, probing, and safety logic. All of those pieces have to happen in the right order, and the controller has to know whether each step actually succeeded.
Before we get too deep into solenoids and sensor logic, a quick word from the sponsor. This episode is presented by PwnCNC. PwnCNC provides standard and automatic tool changing spindle systems, MASSO controller conversions, ISO, 20 tool holders, tool forks, magnetic tool cups, dust collection, and the supporting hardware needed to build a more capable CNC system. If you are planning an ATC upgrade and are unsure which pieces apply to your machine, visit PwnCNC.com. You can browse the available systems and send the team your machine, controller, and current spindle information before ordering.
A few good photographs and an exact model number can prevent a great deal of guesswork.
PwnCNC, helping keep the expensive mystery boxes to a minimum.
That is not our official slogan, but I'll allow it.
Let's start with the basic distinction. What can an ordinary CNC controller usually do with a spindle?
Many controllers can start and stop a spindle, command its speed, run a tool path, and pause for a manual tool change. That may be everything you need for a standard spindle.
And with a manual tool change, the machine pauses, I walk over, loosen the collet, swap the bit, measure the new tool, and press continue.
Right. You are providing the hands, the eyes, and most of the safety checks. With an ATC, the machine has to replace you in that sequence. It needs to stop the spindle, move to a safe location, release the current tool, place it in the correct cup or fork, retrieve the next tool, clamp it, confirm that it is secure, measure or apply the correct tool length, and resume the program.
So the ATC spindle is just one actor in a much larger stage production.
That is a good way to put it. The spindle has the mechanical drawbar and pneumatic release mechanism, but the controller is the stage manager. If it misses a cue, the show gets exciting for all the wrong reasons.
And I assume the tool might not actually be clamped is one of those wrong reasons.
Yes. A controller should not simply energize a valve, wait half a second, and assume everything worked. A well-integrated system uses sensor feedback to confirm whether the drawbar is clamped, released, or in a no-tool state. If the expected sensor state is not present, the cycle should stop instead of continuing.
That sounds less like a fancy spindle command and more like a coordinated machine process.
It is. That is the key idea for this entire episode.
Suppose I buy an ATC spindle, but my controller cannot automate all of that yet. Is the spindle useless until I replace the controller?
Often, no. An ATC spindle can generally operate as a spindle, while tools are changed manually or with a partially assisted process, provided the controller can control the spindle and the pneumatic tool release is set up correctly.
What does manually look like when the spindle has a pneumatic drawbar? I'm not putting 2 wrenches on an ISO 20 holder.
Correct. You would normally stop the spindle, position it safely, activate the tool release function, remove or insert the holder by hand, then confirm the tool is clamped. The air system still operates the drawbar. The machine simply is not traveling to a tool rack and completing the entire sequence unattended.
So that can be a stepping stone.
Yes, it can be useful while testing the spindle and VFD, finishing the pneumatic system, developing tool change macros, or planning a later controller upgrade. Some owners also want the repeatable ISO 20 holder format before they are ready to automate storage and retrieval.
But we should be precise with the language. Owning an ATC spindle and pressing a release button is not the same thing as having an automatic tool changer.
Exactly. It is an ATC-capable spindle being used in a manual or assisted workflow.
Now we get to MASSO. If it is not absolutely required, why is it a PwnCNC supported platform?
Because MASSO is designed to coordinate the collection of inputs, outputs, motion, offsets, and logic that an ATC needs. More importantly, it gives us a known platform that we can configure, test, document, and support as a complete system.
Walk me through one tool change from the controller's point of view.
The controller first needs to stop the spindle and make sure it is safe to proceed. It moves to a defined tool change position. Depending on the layout, it travels to the correct cup or fork, activates the pneumatic release, and checks the drawbar sensor state. It unloads the current tool, moves to the next tool, loads it, commands the drawbar to clamp, and confirms the new tool is actually secured.
Then it measures the tool?
Either it measures the tool or applies a stored tool length offset, depending on the workflow. Then it returns to the correct location and resumes the tool path. Throughout the sequence, the controller needs defined safe positions and predictable behavior if something fails or the emergency stop is pressed.
That is a lot of opportunities for the phrase "close enough" to become a very bad engineering decision.
There is very little room for close enough when a spindle is holding a sharp tool at 18,000 revolutions per minute.
Fair.
PwnCNC supports ATC installations built around MASSO G3 controllers and offers core and advanced conversion paths. The exact choice depends on the machine, the required inputs and outputs, and what else the owner expects to add.
Let's address the question, listeners, with BuildBotics, Onefinity Redline, Open Builds, CNC, Linux CNC, or Mach 4 are probably asking, can my controller do it?
Some third-party controllers may support some or all of an ATC workflow, but the answer has to be verified for the exact controller, software version, machine, VFD, spindle, sensors, and pneumatic hardware. A controller having one spare output for a solenoid does not automatically make it a complete ATC controller.
What should someone look for?
Automatic tool change commands or customizable macros, enough pneumatic outputs, sensor inputs for clamp and release states, tool length probing, tool offsets, safe machine positioning, appropriate emergency stop behavior, and the required M codes. It also needs a supported way to communicate with the VFD for spindle control.
Could a capable person create all of that in Linux CNC or Mach 4?
Potentially, yes. Those platforms can be highly configurable, but technically possible, and a documented plug-and-play PwnCNC installation are two different promises. Custom integration requires the person building it to own the configuration, testing, and troubleshooting.
That distinction matters. You can sell compatible hardware without claiming to be the integration department for every controller ever made.
Exactly. We can help identify the PwnCNC hardware and explain its requirements. We cannot responsibly imply that every third-party controller and machine combination has been fully verified. For example, a CNC-based system may be able to operate the spindle, but the complete ATC workflow should be confirmed with CNC before anyone treats it as plug and play.
So if the controller manufacturer says, yes, here is the documented ATC process for this exact model, that is meaningful. If a forum comment says, I bet Output 3 could do it, perhaps keep researching.
That would be wise.
Time for a quick vocabulary trap. If I tell you I use VCarve Pro, have I identified my controller?
No, you have identified your design or CAM software. VCarve Pro, Fusion, and Carbide Create can generate toolpaths and tool change calls, but they do not directly operate the machine's sensors, pneumatics, or spindle.
The CAM creates the instructions, the machine controller carries them out.
Correct. When evaluating ATC compatibility, we need the actual controller. MASSO, BuildBotix, Onefinity Redline, OpenBuild's Blackbox, CNC SLB-EXT, Linux CNC, Mach 4, or whatever is physically controlling the machine.
In other words, I use Fusion answers a different question.
Exactly. It is useful information later, especially when generating multi-tool programs, but it does not tell us whether the machine can perform the change.
Here is the optimistic budget question. Can I add a solenoid and a bracket to my current spindle and turn it into an ATC?
No. A standard manual spindle does not become an ATC spindle through software or an external air valve. A purpose-built ATC spindle contains a pneumatic drawbar, a tool clamping mechanism, clamp and release sensors, an ATC-compatible spindle body, and a matching tool holder system.
So the important machinery is inside the spindle.
Yes, if you currently have a standard PwnCNC spindle, moving to automatic tool changing generally means replacing the spindle motor with an ATC model and using the matching VFD configuration.
That probably affects the decision for someone buying a standard spindle today, but dreaming about ATC next year.
It should. If ATC is a serious future goal, plan the system architecture early. You may still choose a standard spindle now for budget reasons, but do it knowing that the motor itself will not simply transform later.
Let's build the shopping list beyond the spindle and controller. What else does a complete ATC system need?
Clean, dry compressed air, an appropriate filter and regulator, pneumatic tubing and fittings, solenoid valves, control wiring, ISO 20 or another compatible tool holder format, a rack, forks, or tool cups, a tool length setter or touch plate, and enough machine clearance for the entire sequence.
The compressor cannot just produce the right pressure once and then slowly lose the will to live?
Correct. It needs to maintain the required pressure and airflow through repeated tool changes. A compressor that is fine for an occasional puff of air may not be adequate for reliable drawbar operation.
And the air needs to be clean and dry because moisture and debris are not welcome guests in pneumatic hardware.
Exactly. Reliability depends on more than the number shown on the pressure gauge.
PwnCNC offers ISO 20 holders and several ways to store them, right?
Yes, we offer ISO 20 tool holders, ISO 20 forks, and magnetic tool cups. The right storage choice depends on the machine's travel, available space, and how the spindle approaches the tool.
I assume the rack location has to be reachable without sacrificing half the cutting area or colliding with something.
Right. You have to account for gantry clearance, Z-travel, the length of the tool holder, clamps, the workpiece, and any enclosure walls. Tool storage is part of the machine layout, not an accessory you casually stick wherever an empty corner happens to exist.
And then the dust boot arrives to ruin our beautifully planned choreography.
Dust collection is one of the easiest things to overlook. A boot designed for a trim router or a standard spindle may interfere with the ATC spindle nose, the longer tool holder, the rack, or the motion needed to load and unload tools.
What should listeners measure?
Clearance around the spindle nose and drawbar area, tool holder length, Z-axis travel, the path to every tool position, dust hose routing, and whether the boot must move, retract, or be removed during the tool change.
So even a dust boot that cuts beautifully can be completely incompatible with automation.
Yes. Many ATC layouts use dust collection that remains independent of the tool changing movement. Some owners also keep a separate boot for manual work or relief carving. The important thing is to plan the boot, tool rack, and spindle movement together.
The article specifically discusses OneFinity Redline. What should those owners know?
The Redline controller can control compatible PwnCNC spindle and VFD systems with the appropriate cable and configuration. That confirms spindle control. It does not by itself confirm support for every component and safety step in a third-party automatic tool changing system.
There is our central distinction again.
Yes, for a full ATC installation, confirm the workflow with the ATC manufacturer and OneFinity. Also, do not assume an existing MASSO control cable can simply be cut and fitted with a different connector. The correct cable depends on the controller and whether the PwnCNC VFD is enclosed or unenclosed.
Wire colors are not a universal diplomatic language.
They are not. Pinouts, signals, shielding, grounding, and the VFD communication method all matter.
Why does the enclosure matter to the upgrade path? Isn't a VFD in a box just a VFD in a box?
Not necessarily. An enclosed PwnCNC spindle system may include specific connections and internal provisions that support a documented ATC upgrade. A separate unenclosed VFD does not automatically include those relays, connectors, wiring, or pneumatic controls.
What if someone built a very nice custom enclosure?
It may be completely functional and potentially modifiable, but it is still a custom configuration. PwnCNC does not currently offer every possible enclosure arrangement as a documented DIY conversion kit. We do not want someone purchasing an upgrade intended for one known enclosure and discovering that their custom box lacks half the required connections.
How can a customer help you identify what they actually own?
Send the original order number and clear photos of the VFD enclosure, existing control cables, CNC controller, spindle, and mounting area. Those details are far more reliable than saying, "I bought one of your spindle things a few years ago."
Though technically memorable,
Memorable, but not diagnostic.
a complete ATC conversion can be a substantial purchase. Can someone approach it in stages without creating a dead end?
Yes, if the phases are planned around the final system. One reasonable path is to upgrade the controller first. A MASSO conversion can improve the machine now while creating the input, output, probing, and macro foundation for a later ATC.
That is phase 1. What is phase 2?
Replace the standard spindle with the ATC spindle and matching VFD, then add and configure the pneumatic and control systems.
And phase 3 is the physical layout?
Yes, tool holders, rack or cups, touch-off equipment, and ATC-compatible dust collection. Then the full sequence is tested carefully before it is trusted in normal operation.
What should someone consider when choosing between the MASSO core and advanced conversion options?
The exact machine and intended expansion matter. Think about the number of pneumatic outputs and sensor inputs, tool length probing, tool change macros, additional accessories, and any future machine changes. The goal is to avoid buying phase 1 in a form that blocks phase 2.
Let's finish with a checklist. Imagine I am about to send PwnCNC a message that says, "I want an ATC. What do I buy?" What should I include so Daniel does not have to begin a 12-email scavenger hunt?
Start with the exact CNC machine model and exact controller model. Tell us whether you want full automatic changing now or an ATC spindle used manually at first.
Then the current spindle and VFD?
Yes, include the original order number if it is PwnCNC equipment, plus clear photos of the VFD, enclosure, control cable connections, spindle, mount, and Z-axis area.
Electrical and air details?
Available voltage, compressor specifications, expected pressure and airflow, and weather filtration and moisture control are already installed.
Then the physical plan. How many tools? What holder format? Where the tools might live? How they will be measured and what dust boot is being used.
Correct. Also confirm that the controller supports the required tool change commands, inputs, outputs, offsets, probing routines, safe positions, emergency stop behavior, and VFD communication method.
That sounds like more homework than clicking Add to Cart, but considerably less work than debugging a half-compatible system after it arrives.
Exactly. A TC is extremely useful when the entire system is designed to work together. Buying only the spindle and assuming the rest will sort itself out is where many projects become frustrating.
All right, Daniel, give us the final answer in one clean pass. Does an ATC spindle require a MASSO controller?
No. An ATC spindle can be operated by other compatible controllers, particularly when tools are changed manually or through a partially assisted process. Some third-party platforms may also be capable of a fully automatic workflow when correctly configured. But full automatic tool changing is much more than spindle control. It requires coordinated motion, pneumatics, sensor feedback, tool storage, probing, offsets, and safety logic. MASSO is the platform PwnCNC has chosen to support and verify for complete ATC installations.
So the best controller is not simply the one that can make the spindle spin. It is the one that can safely manage the entire sequence you intend to use, and that you or your supplier can actually support.
That is exactly right.
If you are considering an ATC upgrade, visit PwnCNC.com. Send the exact machine and controller model, photos of the spindle and VFD, available voltage, compressed air details, and the number of tools you want to use. That will help determine whether you need an ATC spindle, a controller conversion, or a complete system.
And it will greatly reduce the number of expensive mystery boxes in your shop.
Still not the official slogan.
Still accurate.
That's it for this episode of the CNC Workshop. Thanks for listening.
Until next time, plan the whole system.
And happy making.